My name is Jasmine 1. This is a video explanation of problem 5 in section 12.5 of Sibylla Beckman's textbook, Mathematics for Elementary Teachers. It is part of a video assignment for my Mathematics for Teacher course at Bridgewater State University. Now, problem 5 in section 12.5 states, make a drawing to show the result of shearing the triangle displayed here into a right triangle. Explain how you know you have sheared the triangle correctly. So here we can see that the triangle displayed, we can see that the base is 1 unit, and we can find the height by illustrating how the height would appear if there were 90 degrees. So we see here, akin to the base, we can see that there's 1, 2, 3, 4, 5 units here. So we know that an area of a triangle is 1/2 of base times height, and thus the area of this triangle is going to be the same as 1/2 of 5 times 1, or 1 times 5. And thus the area will be 5/2 units squared. So we know that the area of the triangle is 5/2 units squared currently. Now, according to Cavalieri's principle, it states that the area of a shape after shearing remains the same as the area of the shape before shearing. So both areas of the shapes before and after being sheared will remain the same. Shearing, according to Sibylla Beckman, shearing is the changing of one shape into a new shape that has the same area. So when one shears a shape, each point of the part that will be moving moves along a line that is parallel to the fixed base. So we already know that the base is this right here, that is listed as 1 unit. We are going to move the point A parallel to the fixed base so that we can create a right triangle. And a right triangle contains a 90-degree angle. You notice that the strips of the triangle, like if we imagine this triangle split into infinitely small strips, infinite strips that are all the different widths, we can imagine that these strips remain the same as we shear this triangle. So these strips that are in this triangle are exactly the same as the ones that they were before. And here we can also see that this triangle has a height of 5 units and a base of 1 unit, which means it is exactly the same as the triangle we found before. So during shearing, what changed and what remained the same? The area of the triangle and the height and the base length all remained the same before and after shearing. What changed was the length of the sides that weren't used. So the length of this side is different than the one we had before, than the pre-sheared triangle.